In order to solve this or verify this identity, we will look at the cosine of t divided by 1 minus sine t is equal to secant t times tangent t. We will recognize that 1 minus sine t we can rewrite or modify by trying to get a sine squared t in the denominator. So we would multiply by the conjugant, or 1 plus sine t, in both the numerator and denominator. If we do that, we are left with the cosine of t times 1 plus sine t. And if we multiply our two terms together, 1 minus sine t times 1 plus sine t, we will get 1 plus sine t minus sine t, or 0 minus sine t squared. We will notice now that 1 minus sine squared t is equal to the cosine of t, cosine squared of t. So we have cosine of t times 1 plus sine t all over the cosine squared of t. One of our cosine t's will cancel with 1 in the denominator, so we'll be left with 1 plus sine t over cosine of t. We can now write this as two fractions, as 1 over the cosine of t plus sine t over cosine t. Using our relationships, 1 over cosine t is secant t, and sine t over cosine t is tangent t, verifying our identity. In the next problem, we will do the same thing. We are looking at the tangent squared divided by secant plus 1, wanting to get to 1 minus cosine all over cosine. We will multiply again by the conjugate of the denominator, or secant x minus 1 in both numerator and denominator. Therefore, we will have the tangent squared of x times secant x minus 1 all over the product of the secant plus 1 times secant minus 1, which is going to give us secant squared of x minus 1. We will now recognize that secant squared x minus 1 is just tangent squared of x, and our tangent squareds will cancel to make 1. Therefore, I'm left with secant x minus 1. We would recognize that secant of x is 1 over cosine of x, and trying to subtract off 1. Finding a common denominator to subtract these two, we would have the cosine of x divided by the cosine of x, and we would now have 1 minus the cosine of x in our numerator all over the cosine of x in our denominator, verifying our identity.